Welcome to my channel. This is part 2 video of development of surfaces. In this video, we're going to discuss about how to uh, do the radial line development. And for that, I choose two problems. One is pentagonal pyramid, then another one is cone. A pentagonal pyramid of size base of 30 mm and height 52 mm stands on its base on HP such that a vertical face is parallel to VP. It is cut by a plane, vertical section plane, perpendicular to VP, inclined at an angle of 40 degree to HP, passing through the axis 32 mm above the base. Draw the sectional top view and develop the lateral surfaces of the truncated pyramid. So normally a section plane is inclined to solid, we call it as truncated solid. So the development of lateral surface of truncated pyramid. Let's start now. Okay, so the first one polygon, it is pyramid, so total number of sides 5. So I choose edge method. Now it is okay. So now the 30 mm. Okay, okay, 30 mm sides. Now the drawing the projectors. Now I draw the XY line. Projectors from up to this. Okay. Then height is 52 mm. Pyramid. So the center point is 52. Now the development of surface is now. Now I would like to draw the horizontal line, then arc, center, start, end. This is our center point. Control. Okay. Now it is the slanting edge. Now the section plane is 32 mm above base. Okay. Now I draw the 32, then horizontal line also. Then is section plane is 40 degree. Okay. Now I draw the line. So just of the ortho 40 degree. For example, at 200 less than 40. Just I move the line from here. This is the actual line. Here's the text. A. Just I copy this. B. C. D. E. Now draw the projectors from first one up to the point A. And second one, line draw from the E. This line up to this one. Then point D. Okay. Then this point C also. Point A. Then this line is from E line up to E point, okay, and this line, okay, D to D, to D, and this point is C up to C point, okay, like this. And only thing, the center point, that is axis line, is not visible because there is no point it's intersected, okay. And for that, what we are doing is now simply drawing a horizontal line up to this point approximately, and draw the line vectors from this point up to this one. Now take the arc, center start end, this is point and this point, okay. Now joining the lines, line weight is 1, okay. Then line weight on the line weight, adding the lines up to, then first one A to E, then E to D, D to C, and this point C to B, and again it comes to A. Okay, this is the point. Right. Now I trim it everything. Remaining portion. Okay, then hatch it. It's hatching line. This is the sectional top view. Then line length will be 30 mm. Okay, no problem. Now the development of surfaces. Now the slanting length to be monitored, and before that, delete it. Before that, using the line up to first point, this point. Second inclination is this point, and third one, this point. Fourth one, this point, and fifth one, this point. Right? Okay. Draw a horizontal line. Okay. Then measure the true length, that is slanting length. So it is 57.92. 57.92. This is slanting length or true length. Now draw a line. So take a center point here somewhere and off the ortho mode. Now okay. Now somewhere else. The length is 57.924. Okay, 92. This is my one line. Then next one, arc, center end arc. This point as a center, this point is end. Now would like to draw the arc like this. Okay, then the same point, center end, center start end. The line is 30 mm. That is the inclined length of the each segment, 5 segment, 30. So again I do this, start, center start end. Okay, now so 30, first one, and second one from this point as center, measure 30, Okay. Now this point as a center, 30. Okay, 30. So total side 1, 2, 3, 4, 5. Now I'm joining this line from this point. Now delete it. Just I move it like this. Now measuring the distance. First one, the part A. Okay, part A up to this line. I change the color of this line as red. Okay. Now measure the distance. I remove it. First line A, 36.28. Now 36.28 from this line. 36.28. Okay. Better you take a single line. Okay. Similarly, next line, that is E line. Okay. I change the color to yellow. The second inclined length of this line, actually measure this line as be 29.39. Actually the length should be measured along the slanting length, true length. Okay. I think snap mode is on. Okay. Okay. 39.62 actually. Along this line, 39.62 of the ortho mode like this. Next one, along the line, first you take the measurement, that is A, then copy. Okay, now B, C, D, and E. And now A. Second line B, second line B. Okay, first line measured. Similarly for top line also 39, 36.62 actually, 36.62. Sorry, line 36.62. Okay, now vertical line. Similarly for this line also, along this line 6.62. Okay, measure this line. Okay, then B line. Okay, this line B line. Okay, from this line. Okay, and measure this. Change the dimension. This green color. Okay, okay, and already is yellow. This is stack as usual. Okay, green color. Measuring the distance. from this point to this point. So 22.28. 22.28. Line measure 22.28. Okay. B. Then come to C. C is about this line. Okay. C line. This is C line. Okay. C. Now measuring the distance 16 actually 16 for C line 16 along line D. So D as this line. Local line dimension 17.94 17.94 D. Okay. Then point E. Point E is yellow. Point E is yellow. Okay. Yellow. See. Point B as line C. Okay. Point E yellow. 29.39. That's the angle straight. And okay. Now joining the lines. So better you on the screen. Then okay. Line weight on the line weight. Now to be and this point and this point, this point, this point, this point. This is the development length of the pyramid, sectional top view and development length of the pyramid. The next problem is the cone of base diameter and height rest with its base on HP, a section plane perpendicular to VP and inclined 30 degree bisect the axis of the cone. Draw the development of surfaces. Again, we come to circle. Now the line weight should be on off. Okay, line weight of the line weight. We come to line weight 5. Okay, diameter 50 mm. Say 25 radius. Then divide 8 parts. Then line. Delete the marker. Okay, now Draw the XY line. Height is 65 mm. 65 it is cone. Now axis bisect the axis. So center point of the axis. Measure the axis. Now draw a line off the ortho mode. Say example, I use length of the line 200 less than 30 degree. Okay. Okay. Now move the line. M enter. Just move the line and you can measure the angle. Check the angle whether it is correct or not. 30 degree. Okay. Okay. Now measure the slanting length 69.64, right? So for the cone, so you have to measure the circumference. Circumference of the cone is 3.14 into d. Okay, 3.14 into 50. That is equal to, let me see, sorry, 3.14. Sorry, not 14. 3.14 into 50. So approximately 157 for circumference. Next one, angle. Angle is equal to 360 into R by L. Radius is 25 divided by length. It is called as 69.64. True length 69.64. Okay, that is equal to first one 25 divided by 69.64.1 into 360 degree, approximately 128 degree, 128.68, 128.68, 128.68 degree. Okay. Now the angle between the each line, so total degree is divided by, that is calci 128.68 divided by 8. So we are dividing the circles into 8 divisions. So 16 degree, approximately 16.09. 16.09 angle between individual line is 16.09 degree, which is inclination between each segment. Okay, total angle, this total angle is segment angle, each segment angle 16.09, right? Circumference is 157. Okay, now increasing this 3. Okay, now so I use this as a radius. Say example, the inclination, some inclination approximately 16.64. Okay, now take an arc, start, center, start, end. The end will be like this. This 157. This is chord length. 157. Okay, arc center, start and length. Start angle, center start. So 157, center start end. Okay, instead of using the degree 128.68, okay, start center angle. So better you on the polar tracking. It's missing. Okay, now use the line center angle. Okay, center start end. 128.68. Yeah, it is correct. Center end arc. 128.68. Okay, this is correct. Now using this line down. So divide the circle into 8 parts. Now check the angles, true length and also inclined. Yeah, 69.64, correct. Then measure the angle is correct or not. Yeah, 16 approximately. The total angle 129 approximately. Right. One actually 128.68. So this is taken as 129. Okay. Now joining this line. I delete this line and the marker. Now measuring the distance. First you would like to draw the horizontal lines and mark the side name is a copy C D E F G N H. Okay. Now first I will to color is red. D also I used the red color. From this line or center line or blue color. Now it's called yellow. Straight line. Ortho mode on. This is green. Next line is red color. And this line also A point is red color. Okay. Now measure the distance one by one, aligned dimension, and now it is of the member. Aligned. First point 45.03. Now 45.03 start center in 45.04. 4. I use this. Okay. Draw the segment like this. Okay. This is for red. Then yellow. Measure the distance from top to up to yellow 41.31. 41.31, that is B and H. 41.31. This is yellow. Okay. Now green. 34.82. This is G and C. And better you copy this, copy B. F G H. Okay, now so both side A is completed. Then this line is H and B, and H and B. It's I would like to mark. So yeah, sample like this, and this one is for B and H. Yeah. Then 34.82, 34.82 for CG. 34.82 C and G. Okay, now I just copy this, and next one blue, from this point to edge point. So 30.09, 30.09 for FD, 30.09 D, 30.09 up to F. Next one, and final one, it is E point, 28.49, 28.49 0.49. Okay, and for this only up to this point. Now I delete this all the. Okay, now joining this line by spline command. Okay, this is final. Nine byte. Just I use like line byte on, and this is the point development of surface of code, and total degree is, sorry, 129, and segment is approximately 16 point something. Then true length, line length will be 69.89, the same length for approximately. Yeah, 69.64. Okay. So thank you very much for your